Good morning, dear friends. Today's video, I will discuss the topic of set theory, that is various operation on sets. So, union of two sets, firstly, I will discuss. The symbol U, this is for the union, is implied to denote the union of two or more sets. If there is a set A union B, red A union B, it is written red A union B, or the union of A and B is defined as a set that consists of all elements belonging to either set A or set B or both. That means this is the definition. Whenever we are talking about A union B, this means it belongs to either the elements of set A or set B or both without any repetition. For example, a is equal to 1, 2, 3, 4 and B is equal to 3, 4, 5, 6. So how I have to take the union? A union B is equal to. That means I have to write all the elements of A as well as B but without any repetition. 1, 2, 3, 4, 5, 6. 3, 4 are the repeated elements. I will take only once. So this is the union. Now I will explain with the Venn diagram. Suppose the union of two sets, we can write X belong to A union B. The union of sets A and B is shown in the shaded area in Venn diagram. This is the A set and this is the B set. This is the universal set U. That means U means universal set. So according to the A union B, the shaded area, this shaded area represents the A union B. That means it included the area of A as well as B and both also. So this shaded area shows the set A union B. This is the Venn diagram of A union B. Now I will discuss the concept of intersection of two sets. That is the intersection of two sets. The intersection of two sets A and B denoted by A intersection B. This is represented by the symbol this. This is for intersection consisting of all elements that are both in A and B. We have to take the common element of A and B. For example, A is equal to 1, 2, B is equal to 2, 3. Here 2 is the element which is common in both the sets. So A intersection B is equal to 2. The intersection of set A and B is shown by the shaded area using a Venn diagram, or it is represented by the Venn diagram. I have U universal set and two set A and B. So I have already discussed in the definition, it is consisting of all the elements that are both in A and B. So this is the area. This is the common portion. This is known as the A intersection B. That means this is the common portion that represent A intersection B. Now I will consider, and intersection is also, I am just also taking that three sets. That means if there are three sets, let us suppose this as the A, this as the B, this as the C. So shaded area shows the set A intersection B intersection C. This portion shows that the common region of A, B and C. So intersection portion is that portion which is common in all the sets. Next is complement of a set. The complement of a set A denoted by A raised power C or A dash is a set of all elements that are in universal set U but not in A. If we are talking about A set, that means its complement consists of all the element of universal set but it does not contain the element of A. For examples, we have universal set 1, 2, 3, 4, 5 and A is 2, 3. We have to take all the element of universal set which are not in A. That means we will ignore 2 and 3. The remaining element in universal set is 1, 4, 5. So A complement is equal to 1, 4, 5. So by Venn diagram, it is shown that this is the universal set and this is the A. According to the definition, we have considered those elements which are not in A. So that's why this area is not taken. We have taken all the area of U, but we have ignored the area of A. So this portion represents A complement. This is a complement. Next is I'm talking about difference. Difference or subtraction of two sets. So how we will discuss the difference? Difference of two sets A and B is defined as A difference B. That means A difference B is this one. It is represented by A difference B. This set consists of elements that are in A but not in B. Because it shows A difference B means it contains element of A but not in B. For example, if A is equal to 1, 2, 3, B is equal to 3, 5, we have to take the elements of A difference B. How we will calculate? We have to take the elements of A which are not in B. That means 3 is the element that is in B but not in A. So we will delete this element, then we are getting 1, 2. Here we also note that A difference B can also be written as A intersection B complement. A difference B is shown by the shaded area using a band diagram. Band diagram, we can show the shaded region which is represent the A difference B. This is a universal set. That means it has two sets A and B. So this is A, this is the B. According to the definition, if we have to calculate A difference B, we have to take the area of A but not B. So this is the whole area of B. We will not take the B region area. We will take only the A portion area. So shaded region, this shaded region shows that we are talking about A difference B. So this is the difference or subtraction of two sets. Now, I will just consider one more definition. Mutually exclusive and disjoint sets. Two sets A and B are mutually exclusive or disjoint if they do not have any shared elements. That means if they have not common element, then we can say this is the disjoint or mutually exclusive. So intersection of the empty set. That means whenever we are taking about the disjoint set, we have to take the intersection. Intersection should be empty set. Empty means we can also write 5 or we can also write empty. There is no common elements. So this is a universal set. This is A set. This is B set. This is C set. That means these are the disjoint. There is no common element. So this show that A intersection B intersection C is equal to 5. So these are the basic operation of set on set. That means I have discussed the union, intersection, complement, difference, and mutually exclusive or disjoint sets. Thanks, dear friend. Please like, share, and subscribe my channel. Don't forget to share with other also.